Tell Kevin we need to redo this wall.
We have to demo it all.
The electricians won't play ball.
Redesign the hall?
I'll tell Nathaniel.
Material recall.
Okie dokie.
They're gonna fire Paul. What did I do?
Make it 3 feet tall.
3 people?
Fire that directing rod.
Yeah, the pipe's too small.
Recall.
Hexagonal.
Horizontal?
Greg! Greg! We need to install
A waterfall.
Cool waterfall.
Be on the same page at every stage with Autodesk Construction Cloud.
Where's Paul?
For this session's discussion, we're going to first start by digging into some of the business benefits gained by using cloud collaboration, and then we'll look into a short overview and demonstration of each of these offerings. After, we'll do a more in-depth demonstration on our main attraction, how connected workflows between Collaborate Pro and Plant 3D can really help bridge the gap with some of the challenges that we face. And lastly, we'll have some time for a Q&A to get to any of the questions that you have that you are throwing in the chat box as we go through this discussion. In a COVID-changed world, the challenges our industry faces seem daunting, and AEC businesses are looking to harness cloud technologies as their new normal for the design practice. With the cloud, it is possible to maintain business continuity so you can work from anywhere on anything with Insight in order to reduce risk and gain efficiency in day-to-day operations. When your teams are disconnected, redundancies and errors multiply, and now you can readily mobilize for anytime, anywhere work, whether it's from home or a remote office or with external partners. Your business needs better visibility and insights into everyday design work, which processes are working for your teams, what communication methods ensure round-trip resolution, and how to reduce the conditions for repeat errors. Insights make project management and resource allocation easier once you have the right tools for risk mitigation, resource prediction, and control. And finally, you also need your connected ecosystem of tools, whether to collaborate on designs or capture feedback or run clash detections on 2 or more models to enable clarity and organization. Now we know that in order to better manage unpredictability and disruptions, you need to empower your team and business to flexibly adapt as requirements change. You don't want another disconnected app. You want your technology investment to span multiple use cases, file types, and workflows. This is possible when data is organized in a common data environment, and access levels are structured for all team members, and when exchange of information can be coordinated or even automated to make it easy for you. Digital transformation is happening at an extraordinary pace, accelerated by the urgent move to remote work, and yet teams, processes, and data remain disconnected. So where do we start? We start with BIM Collaborate Pro, putting data at the center with cloud-based collaboration technologies. BIM Collaborate Pro brings design and coordination teams together by connecting BIM data with construction workflows on a common data environment. BIM Collaborate Pro enables anytime, anywhere access to the design tools you love to use, generating powerful insights to drive better decision making. For the first time ever, Autodesk connects all of this together with BIM Collaborate Pro. Taking a look at the Design Collaboration module of BIM Collaborate Pro. This is where project teams communicate their design updates with each other. Other teams get notified through the project timeline that a new package is now available. To make these changes available to other teams, the structural team creates a package, which is a combination of one or more sets to be shared. This package might include the Revit model, an IFC file, and other supporting documents. Once the structural team has created and shared this package, other teams will be notified via the project timeline in the Design Collaboration module. Here the MEP team sees the new package is available from the structural team. After exploring the package, and review the changes that will impact their model, the MEP team decides to consume the package. This updates the aggregated model view in the design collaboration module, where you will see all consumed models plus your own work in progress model overlaid on top of each other. It's time to shift your perspective. BIM Collaborate Pro provides a better view of your projects, giving you and your team anytime, anywhere access to the tools and information needed, with powerful co-authoring, project management, and model coordination tools. Your team can work together in a secure common data environment, which means more co-working and less reworking. Plan 3D is an Autodesk application targeted to the design and layout of process plant facilities. It has the tools and features designers need to create detailed plant models, including piping, structural, and equipment built on the familiar AutoCAD platform. Using spec-driven technology and standard parts catalogs, designers can streamline the placement of piping equipment, support structures, and other plant components. For this example, we will look at the intelligent P&ID workspace for Plant 3D. We will first place a pump and then the lines to and from the pump. Flow arrows are placed as the piping lines are drawn and can be reversed as necessary. We can set the line sizes and specification through annotation. Then we will proceed to place valves which will automatically align and inherit the line sizes from the line. Inserting reducers automatically creates a size break in the line, and any update to the line specification will automatically be reflected in the part labeling. We can continue the pipe configuration by defining the outlet piping. When control valves are defined, the valve body and the actuator are designated to ensure the correct graphical representation, as well as correctly defining the valve in the database. Drain valves can be set to normally closed, which will automatically change the symbol representation. Once the first pump configuration is now complete, we can simply use AutoCAD functions to copy the pump configurations. In this example, our pumping model will be housed in an industrial building, and we can start by modeling the associated steel and concrete structures. Once the pump supports have been modeled, pumps can be defined using the built-in parametric equipment library. However, it is also possible to model your custom equipment using Inventor, specifying the piping connection points and specifications and then exporting for use in Plant 3D. The Inventor equipment converter in Plant 3D facilitates the transfer of equipment modeled in Inventor, and once in position, the usage and tagging of the equipment can be specified. When the pump arrangement is complete, it can easily be replicated ready for the piping phase. The P&ID can be used for the pumping arrangement and can be referenced at any time during the equipment and pipework modeling. In the 3D model, we can add piping directly using the available modeling tools, or alternatively by accessing parts from the P&ID line list, which automatically transfers the piping specifications and catalog. Pipe connections such as mating flanges and reducing tees is handled automatically, and additional piping parts such as valves can also be drawn from the database via selection from the line list and can be modified at any time, as in this case changing the valve actuator from lever to handwheel type, as well as allowing the external use of custom components. Plant 3D contains a comprehensive library of various items to facilitate the completion of the pipework, such as pipe hangers and clamps, and these can be taken from the parts library and then modified to the right size using the properties panel. Parametric isometric drawings can be automatically created, allowing piping to be checked and configurations to be passed on to the piping fabricators. And finally, piping orthographic drawings can be produced, and generated views are then assembled onto the drawing sheets, where the bills of materials can also be automatically generated from the database. Now for our main attraction. Let's see how these two platforms work together. We will be referring to the previous demos for these examples. After creating our folder structure and collaboration spaces for the required teams, we can now connect our Plant 3D project to the structure. The connection of a Plant 3D project to BIM Collaborate Pro is achieved by using the Share Project tool and then browsing to the appropriate project. The Plant 3D project can be connected to BIM Collaborate Pro at any stage of the project, be it a new, partially or fully completed project. Once the connection process is complete, the Plant project will be fully cloud-powered and will be available for use and sharing immediately. Now that the Plant project is hosted in the cloud, we can see our Plant 3D project folder structure in Docs. However, in order to maintain full control over the data, the administrator will move the Plant 3D folder structure to the Plant folder, making it accessible to all of the Plant team members and is ready for sharing to the wider project team. Back in Plant 3D, we can now open our project from the Open Collaboration project option, and the relevant folder structure will be updated and ready for use. Plant 3D models or drawings can then be checked out, protecting them from parallel changes by other members of the team, and this can be done with the checkout tool or by double-clicking the asset. The asset can then be checked back in at any stage to save changes and relinquish control, ready for other members to access them. Reference drawings that may have been shared by other members of the project team, as in this case from the structural team, can be attached from the cloud using the Attach tool. This allows users to browse the Plant 3D cloud data structure, select the required asset, and attach it as an XREF without the need to transfer the file locally, maintaining data security and integrity. Next, we will see how teams can collaborate and resolve issues as the project progresses. For this example, we will look at the tools that will help us effectively manage data and communications between team members as the design cycle continues. The first will be the markup tool. There are a number of options that allow to draw attention to areas of the drawing, such as cloud boxes and polygons. These markups can be linked to data outside of the current asset for reference. Other tools to draw attention to specific items within the drawings are text that can also be added and color-coded for visual differentiation. Each of these markups can be published for viewing by team members who have appropriate permissions or kept private for personal notes. And these are then reflected in the file status. If more traceability is required regarding, for example, communications of design concerns, then the issue tool can be utilized. Areas of specific concern can be tagged and information regarding the issue can be entered. The issue can be assigned to a specific individual or group, dates for a response can be set, and a number of optional fields populated, including notes about the specifics of the issue. Once submitted, the assigned project manager will be notified that an issue has been assigned to them, and they can review the issue to identify the appropriate action required. In this example, our pipe modeler is required to make a change to the hand wheel height on a specific valve. And once the adjustment has been made, the change can then be checked in and the notes added to the issue comment history. Having been notified that the issue has been updated, the initiator can review the changes made and close the issue down if appropriate. This is then reflected in the status. Looking at a wider overview of the design collaboration module. The first stage will be to set up the collaboration teams. As we set up those teams, we can provide a name for the team and either select a predefined folder or allow design collaboration to create and assign one automatically. It is also possible to define and create a team-dedicated coordination space to assist in aggregating team models. Once the team is created, the team members are specified together with their permission level. And once this is completed, the folder structure in Docs is created with the folder level permissions already defined. The project timeline is where teams visualize and interact with shared data. In order for a member team to share data, they click the plus sign on their team's timeline and select the data they want to share. This package of data will need to be named in order to identify it and then shared to the project timeline. As the data is shared to the project timeline, it appears as color-coded icons, where solid icons indicate the data already consumed and where empty icons indicate data available for consumption. When a team identifies data on the timeline that may be useful, the team member can click on the package in the project timeline and then explore the data before deciding on whether to accept it. If the decision is to accept the data, the team member clicks on the Consume button and the data is transferred back to the team's data structures. Teams sharing data in this way can utilize that information to progress the project designs.
Okay, thank you guys. So I would also like to hear from you guys. So if anybody has any questions, please drop it faster in the chat box. I just want to thank you guys again for joining us for this webinar and taking the time. And if there's anything you guys would like to know or need further information about, if you don't want to drop some questions now, you can always contact us. So here are the details. And if you do want the recordings, please ask also on request on this email. And then I also would like to remind you guys that we do have a webinar again tomorrow at the same time. So also would like to see you guys there. Thanks again, guys. So that will be it from my side. If there's no further questions, we will be ending off the session.